Good morning, good afternoon. It's wonderful to have you here. Welcome to Imperial College London's series Great Minds, Conversation with Winston Wong. I'd like to start by telling you a little bit about Imperial College London. We are a world-leading science, engineering, medicine, and business-focused university, having about 8,000 staff and 20,000 students pursuing the forefront of research, education, and innovation. One of the greatest measures of our success as a top university is through the incredible accomplishments of our students and alumni. We have about 200,000 alumni worldwide. We decided to share some of our amazing alumni experiences and get them to discuss their ideas and their inspirations through this series we are calling Great Minds. Today we have with us a Taiwanese entrepreneur, scientist, philanthropist, and principal founder of the GRACE THW Group, Dr. Winston Wong. Winston has served as chairman and chief executive officer of GRACE since 1996. Winston has been made an honorary officer of the Order of the British Empire, OBE, in recognition for his services to education and research in the UK and to UK-Taiwan education relations through the Foreign Commonwealth Office Chevening Scholarships. Dr. Wong holds degrees in physics, applied optics, and chemical engineering from Imperial. He is currently a visiting professor at Imperial's Institute of Biomedical Engineering and has generously supported our Center for Bio-Inspired Technology and the Winston Wong Chair in Biomedical Circuits. Winston's deep and long traditions with Imperial include receiving an honorary degree from the college in 2007 in the presence of Her Majesty Queen Elizabeth II. I'm pleased that Winston's family have maintained close links with Imperial, as his son Winston Wong Jr. also holds a PhD from the college. Winston, it's wonderful to have you with us today, and we're very much looking forward to hearing your experiences and your ideas and your impressions. You've had a really amazing life, and I look forward to talking about your experiences. But I thought we'd start with THW GRACE company. And I'm really excited about the technology that you make at GRACE. I was really excited to learn about how this technology is in all of our telephones and many, many devices. Could you tell us about the main product that you make at GRACE, please?
Maybe. Okay.
There you are.
Okay. Thank you very much, Alice, and I'm very honored to participate in this program. And it's called Great Mind. I don't regard myself as one with a great mind. There are many people with much more beautiful and great mind than myself. But I'm very proud and very honored to have a lifelong association with Imperial College. And when I entered Imperial College, was not like what Alice said in medicine and in business and in all this. When I was in Imperial College, it was simply the Imperial College of Science and Technology. Consists of Royal College of Science, Royal School of Mines, and the City Guild. But I'm very happy to see Imperial College expand, and now Imperial College is such a wonderful, for example, medical institutions, which has contributed greatly to the recent pandemic. But talking about my own career is, yes, it is interesting, but maybe the word turbulence would more closely describe my own life. But that is very much to do with, I remember when I was doing my PhD with Professor Felix Weinberg, my PhD thesis was an optical study of turbulence within fireproof. So this describes my life very well. I mean, my life has always been a very turbulent life within some kind of a fireproof, and sometimes goes up and sometimes goes down. But just to introduce, like Eddie said, about my company, actually, I studied the physics at Imperial College, and then a master's degree in applied optics, and then a PhD in combustion physics from the Department of Chemical Engineering.
But that was the perfect background for what you do today at GRACE. You're an entrepreneur who's made
Yes.
some incredible materials. So tell us about them.
My career, I spent a lot of time because I was very intrigued by lasers, interferometry, and when lasers are very important in lithography. Okay, so I was very intrigued and interested in semiconductors from a very early stage. And I was responsible for two fabs, building two semiconductor fabs, one in Taiwan, and in about 1993, 1994 period, called Nanya Technology, specializing in production of DRAMs, that dynamic random access memory. At that time, in 1994, 95, it was 0.18 micron technology was considered to be at the forefront of the semiconductor fabrication technology. Of course, now it's 5 nanometers, maybe even 3 nanometers now. So up to now, the Moore's law seems to hold up very well. But I don't think it will hold up very well in the future. So I built that. And then in the year 2000, I built another fab in Shanghai. But it's not my fab. I built the fab, but for the Shanghai government. I don't have enough money to build the fab. Back then, it's still very expensive. Now it's even more expensive. Back then, you were talking about $1 billion fab. Now you're talking about more than $10 billion. So I was interested in semiconductors, but when I started my own GRACE group, of course, I do not have near enough capital for semiconductors. So I went into other electronic materials. So the product I am focusing on now is several. One is glass fabric. Glass fabric is manufactured from the raw material, just sand, silicon sand, but of course a special sand with many other minerals like boric acid and all this in a mixture of sand. And we purchased the sand, a special grade of sand from Mongolia. So because normally in the glass fiber, you melt in the very big furnace, maybe it can be heated by natural gas, 30,000 ton furnace, but not if you want to produce the very advanced, very fine glass filament. We do that in an electric furnace that we partly develop ourselves. And then we are able to now to produce a 4 micron in diameter glass fiber. That is the thinnest glass fiber in existence in the world. There are only about 3 to 4 companies able to do that worldwide. One is the GRACE Group, and the others are all in Japan.
That's incredibly thin. That's like 1/20th of the width of your hair.
1/20th of the width of your hair. Your hair is normally about 80 microns. So it is 4 microns. And then we take this and we weave into a glass fabric. And from that glass fabric, the big technology is in the surface treatment. There are chemical treatment, which is we have many patents on the chemical surface treatment of the fabric, and then it is the fabric is sandwiched between copper foil, normally 1 ounce, ½ ounce copper foil, that made into a copper clad laminate. And then you sell the copper clad laminate to the printed circuit board manufacturers. They etch the circuit on the copper clad laminate, and they sell the printed circuit board to a motherboard manufacturer. That this manufacturer put on all the electronic components like resistors, inductors, semiconductors. And then this is the basis of all the electronics equipment we have today. Like now we have to use the video conference with our personal computers or with your mobile phone, your iPhone inside. Has to have several layers of printed circuit board, and inside each layer there is a layer of the glass fabric. And the more smaller, the more advanced. That is, if you use more advanced semiconductor, you want the product to be more compact and lightweighted. You have to have a glass fabric with very low capacitance. So we measure it by decay number. That has to go lower and lower and lower. And so this is very important in the basic material for all electronics. That is what we make, because in China now, very competitive.
That's well, and that's so, I mean, it's really important to have this, it's an insulating material then, and it's on ubiquitous, and we don't think about it, but it's in all of our electronics. And so that's really fabulous. And GRACE is doing well through the pandemic, and you listed the Shanghai Exchange a couple years ago. Maybe you can tell us about
maybe last year, maybe it was unfortunate. We have the glass fiber plant right in Huangshi. Huangshi is inside the province called Hubei, and that is the center of the pandemic in China. Okay, it's right at the center, and so the plant was shut down. For almost 3 months, and there was no. At that time, you have, of course, you have all the operators or all the staff in the plant need to be paid. You have all the expenses with almost zero income. Okay, so that's what you have to put up with. So in Chinese we say in Taiwanese. In Taiwan we say I say in Taiwanese now, 后天爱春后来牛. That means in a sunny day you have to store enough food for the raining day. Okay, that's why in any business, you have to think of a scenario similar to something like that, but you really don't expect something as bad as that. Okay, so you need to a company's lifeblood is the cash flow. A company can be big, can have lots of assets, but a company can go under if your cash flow is prolonged with negative cash flow. So you have to prepare enough cash flow for the raining day. And fortunately, our philosophy is such. Of course, at that time we discussed and we talked, and of course we have some cash reserves, and then we have very good credit with the banks also. So we were able to weather through that. But amazingly, China controlled the pandemic very well indeed. So by the third quarter of last year, we were back in normal. And now, because of the requirement for electronics, because like now we have video conferences, work at home becomes more normal, and home entertainment with electronics, so the demand for electronics went up quite a lot. So our businesses now is probably the best ever at the present time.
Yeah, you must be very busy. I wonder, I'd like to hear about a new product I know you're excited about that you're just developing for the future.
Yes, we basically, our line is electronic material from glass fiber, glass fabric, electronic grade epoxy resin, copper clad laminate. We have a series of electronic basic materials. And then, because I have my background also, when I worked for United States, my first job was in environmental engineering, because I at that time was designing an incinerator for industrial waste gas. So I has always been, for so many decades, very environmentally conscious. So now, recently, in the past 3 years, we developed a paper made of basically calcium carbonate and the polypropylene. And now this is in only the very beginning stage, because we went through the process, we developed the unique processes for this product, and now we managed to make elementary school and kindergarten textbooks out of this paper. And this paper, of course, needs no trees. You don't need to cut down trees. It's basically made of rock from calcium carbonate and polypropylene. So the paper itself, especially the little kids, they spill their food, their milk, their drinks on their textbooks, and but this paper would just need to wipe it off. That can be very lasting, and the textbooks can really can pass down to younger kids in the school or in the kindergarten. So this is in the experimental stage in an elementary school in China, in Wuxi, China, right now. And so this is in the very beginning stage. We call this environmental paper. And I hope
that's exciting. I hope you'll make some for some of us who are messy with our coffee cups, and we can wipe off our paper as well.
I can send you. It's very 我们那个书有吧？哈，那 kindergarten 的，yeah. We show you the kindergarten and the elementary school textbooks now in Wuxi, China. Some of the schools are already starting to use this.
So let's go back to when you were a school child and how you decided. You said from an early age you were interested in these things. How did you decide that you were excited about science?
Actually, when you were a child or when you were very young, I don't know about other people, but at least I was a dreamer. I tend to dream a lot. I tend to go into my own world and maybe into some kind of hero worshiping and all this. And at that time, there was the Nobel Prize was a big deal at that time. It's not so much now, but it was a big deal at that time. There was two guys originally from Taiwan, but of course studied in America, and later they will all become American citizens. Was Dr. Yang and Dr. Lee. They got Nobel Prize in physics in their early 30s. In the early, when they were only 30-something, from the theory of parity. That was a big deal. And it was when I was very young, and when I was at school. Actually, I was a pretty good student at school, and ever since elementary school. So I was these two people became my hero, and I have dreams of also getting a Nobel Prize in physics. And this without knowing how difficult it might be, I actually went to Imperial College studying physics. But very soon after I was in the first year, I knew I was not capable to be at the top of physics, because there were so many people in my class that were much better than I was. I realized that very soon.
Yeah, of course, you're interested in physics, you want to win a Nobel Prize, you come to Imperial College London, of course. And you did pursue postgraduate studies. You did carry on, as you mentioned, in optics and combustion. How did you decide to stay for graduate school?
I think I was basically tendency towards the academic. I love academic. I love schoolwork. I love to do research also, and of course at that time, and Imperial had several Nobel Prize winners. One in theoretical physics, Professor Salam, and one which gave him gave a lecture at Imperial College. He was also from Imperial College, Professor Dennis Gabon, the father of holography. And I was very intrigued with holography. And that's why after I finished my degree, I went upstairs in the Department of Physics and did the Master MSc in Applied Optics. And then that was I was doing experiment with at that time argon laser holograms. And then after I finished my MSc, of course, back home, my family wanted me to come back to Taiwan, but I had a really desire to go on to do a PhD, but my father did not like that because he thinks it's better to get a business experience. And a PhD has very little value, he said, in the future business. So I need financial support. And then at Imperial is very good. The physics department introduced me to Professor Felix Weinberg. And then I had financial support. And of course, Professor Felix Weinberg was already very well known for his research in combustion physics. And it was involved optics too, because the first book he wrote was the optics of flames. Okay, so he's using optical method to study combustion. So I fitted right in.
Yes. Yes. And that of course you've since then you've designed a furnace for your special glass. So it all fits right in. And I'm wondering, I mean, where Professor Weinberg is so inspiring. Much has been written about him. His memoir of his being a teenager in the Nazi concentration camps is very moving. He must have been a wonderful person to work with. Can you tell us a little bit about your memories of Felix Weinberg?
I think it would be very interesting for every one of you, if you have a chance at all, to pick up a book from the bookshop or from Amazon by Professor Felix Weinberg called Boys 30529. Boys 30529. It's in fact his autobiography. And he was such an inspiring person, and he was at that period he was almost like a father to me. And I know I was because my father cut off all my economic support. I was a poor student in London, and Felix not only was my PhD supervisor, he very often invited me to go to his home, so I know his wife Jill and his kids very well. And one of his son is a professor at Imperial now, and Professor Peter Weinberg. We become very close. In fact, he has a great impact on my life, other than my supervisor. I remember one time he invited me to, at that time a very, very big treat, because to go to a steakhouse for a student was very rare event indeed. And he showed me his tattoo on his arm that he received when he was at Auschwitz. He went to several concentration camps. Normally one would eat a steak, medium or rare or never recommend that. But Felix always had his steak, I remember, well done. Because I think people with that sort of experience, because I think his mother and his sister died in the concentration camp. And he was digging graves for these people as a very young man. He was, I think, 16 at that time. So people have different reactions. Some people becomes very, very cruel. Some people become very kind. They seem to go very extremes. Felix was very kind type. And he didn't want to eat steak with blood on them. This has persisted to me. I go to a steakhouse and I always have my steak well done. Right now, okay? So I think he has a great deal of influence on me, so uh, after I came back to Taiwan, I invited Felix to come to Taiwan twice. He was here, and I was able to host him in Taipei, and I was very happy that he was able to come, and he was very happy. And so we have a lifetime friendship. My teacher and my friend, Felix Weinberg.
That's marvelous. Thank you. But I'm sure you were tempted to stay as a colleague of Felix Weinberg, but he was unable to get you to stay at Imperial, and you went off, as you said, became an environmental engineer. How did that happen?
Oh, that was, as I just described, when I was young, I don't think about much. Sometimes you could say quite reckless, and in the sense that I studied, I was interested to follow Professor Weinberg. I was interested to do my research and write my papers and my dissertation. But other than that, I I met this girl, and just before I had I finished my PhD, and then her parents resides in London. She went to art school in London, and then I got married in 1975 with her. So suddenly, instead of living on the financial support that Felix gave it to me from the Joint Fire Research Center, I had to support two people. So I couldn't stay in academic. I had to look for a job with better pay. So I went to work in USA. I went to work for a company called PPG Industries. At that time was called Pittsburgh Plate Glass, and now it's just called PPG Industries. In their Louisiana plant called Lake Charles, Louisiana, very small town, U.S. town, 80,000 people. And at that time, I think it was in the beginning of people are paying attention to environmental matters. The EPA, the Texas Air Control Board, were just starting their regulations, and the plant was at that time wanting to build an incinerator for their industrial gases, and they also want to build a wastewater treatment plant. That's when I was with my combustion physics background. I joined the company, and the first job was to design, as part of a team, to design an incinerator for industrial waste. That was the beginning of my career in environmental engineering.
Well, and that environmental focus has stayed with you through all of your companies. I know you went and used your environmental background as you went to FPG, from PPG to Formosa Plastics Corporation, and you helped them with their manufacturing plants in the US. And they focused on plastics and fibers, but as you mentioned, you started electronics. You were interested in semiconductors. How can you tell us about Nanya Tech and how you got going in those early years of the semiconductor work?
As you say, you are quite right to say, I started with FPG because of environmental. They were trying to build at that time, they have idea to build a chemical plant in Texas. They suddenly found out that they need approval by the EPA and also the Texas Air Control Board. So actually, to make the long story short, I joined to write the environmental impact assessment for them. And then when I finished, I came back to Taiwan, and they are all in plastics, basically in fibers and plastics, which I knew very, very little indeed. So I couldn't make much contribution to plastics. So I started electronic. I started electronic section, and I also started the environmental engineering section at Formosa Plastic Group. The electronic section, of course, I started with more basic materials we started with copper foil, which can make very similar process to plastics, but it's made from with copper cables and things like that, with the drum, and actually this was a very interesting experience because Japan was the predominant supplier of copper foil for electronics, but they did not want to sell the technology. So in the end, I had to purchase the technology from the land East Germany. So I went to East Germany. It was a very interesting experience. I went to East Germany. They have a very small scale production process. And actually, the East Germans came over to Taipei as well. So it was a very, very interesting experience. I went through from West Berlin to East Berlin and went through the guard post where everything was examined. You went through to East Germany. You immediately feel a very different environment. I think this was a very valuable experience, which you can never repeat again. Of course, it does not exist anymore. The Berlin Wall was still there at that time. So we started with copper foil, which we started a small pilot plant, and then we expanded it. And now Nanya is probably the biggest copper foil electronic grade copper foil producer in the world today.
Yes, that's amazing. And from those early days, of course, Taiwan is an amazing center for semiconductor industry. We have a couple questions from our audience. I want to say one from Pantelis Giorgio. He says, an amazing journey, Winston. We are currently experiencing unprecedented times in the semiconductor industry as there is a global microchip shortage. Taiwan, being a world leader in this space, is working at full capacity to service this, but more is needed. I would like to hear your thoughts on what the future holds to address this increasing global demand for semiconductors.
Wow, that's a big question. You know, I know TSMC because I was the very first directors of TSMC when it started. Actually, we hired Morris Chang. And Morris Chang now claimed that he's the founder of TSMC, which of course he had great contributions, but we hired Morris Chang from the government started TSMC. The government of Taiwan started TSMC. And I was one of the first directors of TSMC. Even I was amazed at the progress of TSMC up to now. I can say I studied and I started semiconductor fabs. I still don't know how you make 3 nanometer with. Really, I still don't know them. because that is beyond also the deep UV lithography. So anyway, but your question is because I think partly because it's so difficult to set up a fab. It costs a lot, but also it takes experience. You cannot just have lots of money and then you try to build up a semiconductor industry. It doesn't work that way. TSMC took about 20 years to be successful because it takes step-by-step experience with education of your people, with development of your in-house technology, very important. Every step from lithography to all the steps, maybe there are 3,000 steps in the manufacture of semiconductors, and you end up with each chip of about 60-some layers. Okay, about maybe average 66 layers, if I remember right. Every layer is very important, and in the manufacturing process, in the fab, is not touched by human hand at all. Okay, you cannot touch it, and so all the processes have to be just right, and the engineers are there for troubleshooting. There's always trouble. There's always troubleshooting, and so it is a very difficult process, especially for the very advanced process. The so-called advanced process, I think, is anything that is better than 28 nanometers. But I think right now, of course, America even is a national policy now to support semiconductors. This is very rare. American politics usually, leave it to the free market to do that, but very rare. For this time, President Biden even said they will have allocation of the money for the semiconductor industry, which is very, very, very rare indeed, which is against what America has done for a long time. They actually have allocate money to help the semiconductor industry. Of course, the sad thing about was Intel. Intel used to be #1 in the semiconductor manufacture. But I'm not here to go through why I think Intel has fallen behind. But I think it will take some time for Intel to catch up. But with the emphasis, with the grounding, with the background of Intel, with the people, the excellent people they have in Intel, is only to take the right policy, right management for Intel to be able to produce a lot of semiconductors to meet the demand, because the demand is only going to get more because of the experience through the pandemic. There will be people returning to work in the office, but there still remain a portion who will remain to work from home, especially in the United States. So the demand for electronic material, especially now, the automobile demand for electronics will start to increase. People expect more intelligent cars, more inside the car electronic entertainment, and better telecommunications inside automobile. So more chips will be necessary. And I think now, of course, TSMC is going to build a plant in the United States as well. So increase that will take 3 years, 2 or 3 years. So I think the the semiconductor shortage will not be met very quickly, but in 2 or 3 years, I think the supply will catch up with demand.
Thank you. So it's the combination of market and government policy.
Yes.
I have another question, a little more environmental, from Mark. What is your view of life cycle analysis and the idea that manufacturers should remain responsible for their products throughout the product's life?
I think that's a very good question. I think this is a concept that the manufacturers are getting more and more into right now. I think the common objective, traditionally, the company objective is for the maximum benefit of the shareholders. And then more and more social responsibility. Company become more and more important. The objective, not only the shareholders and the employees, but become more responsible for all stakeholders. Okay, let's include social responsibility. I think this is more and more important. The consumers are more and more environmentally mindset in a lot of consumers. A company that is responsible for the environment, environmentally friendly products are more and more welcomed. And I think not only welcomed, in the future, it will be demanded by the consumers. So the life cycle, like you are saying, the semiconductor life cycle, for example, semiconductors use a lot of toxic materials in their process. The etching, the hydrogen fluoride use an etching, very pure, 0.9999 purity of hydrogen fluoride has to be in their product cycle, in the manufactured product has to be treated well. Like I said, in the beginning, the waste gases have been treated well. The waste gas and water needs to be recycled. Materials, not only the product life cycle, after the product is shipped out to the environment, the used products need to be recycled also. But I think this is more and more necessary, and a manufacturer will be not only responsible for the quality of their product, but be responsible for every process of the product life cycle. And more than that, even after they sell the product, the product, many of the products need to come back and recycle. I think this is very, very important. I think we only have one planet. And I think what happened in California, in Canada now, with a temperature of nearly 50 degrees centigrade, we know the importance. We feel the importance of environmentally friendly future we must create for our next generation.
Thank you. There are a couple of questions. There's an anonymous question. Taiwan is such a wonderful place, and the Taiwanese seem to have a fascination with everything contemporary, with a love of everything new. How much has the Taiwanese approach to creativity and innovation and the Taiwanese philosophy of life in general contributed to your own approach to business? And then I have a question from Chris Tumazu. So the philosophical question and then a practical question.
I think, take myself. I virtually grew up in the UK. Okay, and I was educated in Imperial College. Imperial College made what I am today with all my education. All my grown-up education was done at Imperial College, UK. Of course, I work in Taiwan, I work in China, and I think it is not so much Taiwan. I think it's very much global now. It's very much global. I think my mindset is what I've learned from the UK and the culture in Taiwan. Also, I think the very fine culture in Taiwan is really family education. Okay, family is the center of education in Taiwan. The respect for the elders is very important in Taiwan, and innovation, of course, in Taiwan is usually Taiwan look up to the West. Everything from America is very good. Only a couple of decades ago, people like to go to very new things like McDonald's, Kentucky Fried Chicken, and all this. And then it's a blend of Western, and then now people also realize that Taiwanese own culture. So it's a blend. Even the food is a blend of Taiwanese food, Western food, and the culture the same. Our worship of many gods and monolithic region of the West, they blend into Taiwan. So Taiwan is a very rare country worldwide that is very, very tolerant to all religions. Taiwan has zero religious prejudice. Taiwan is friendly to the Muslims, to the Buddhists, to the Catholics, and to the Christians, to all religions. I think this is a very fine point about Taiwan. Taiwan has no religious prejudice. Taiwan has virtually no racial prejudice. Taiwan welcomes everybody from the world. I think this is Taiwan.
And you are indeed a globalist and someone with a very international mindset that's very inspiring. Chris Tumazu asks, he reminds us, Winston, you were pivotal in helping us set up the UK's first Institute of Biomedical Engineering at Imperial. And without your vision and support, it wouldn't have happened. Do you see a post-COVID world, in a post-COVID world, the applications of semiconductors to healthcare becoming more important?
I think Chris Thomas is too humble. That Institute of Bio-Inspired Engineering will not be possible without Chris Thomas. Okay, I think Chris Thomas is number one in the creation of that institution. Okay, I just help him. That's all. Okay. I think he is still the inspiring center for this, and it goes right to his own question. He's making semiconductors a pivotal role in biomedical engineering. He is making even in the COVID-19 detection. Of COVID-19, he's using semiconductors for that. Okay, he's using ISFET for that. So I think he proved himself through the institute that biomedical engineering and semiconductors complement one another. And GRACE THW is instrumental, is the most inspiring center for the development of the application of semiconductors in life sciences.
Yes, I would agree. I would agree. His marvelous invention to bring a DNA sequence directly into an electric signal is revolutionizing detection. And DNA Nudge and DNA Electronics are both fantastic companies taking that out to work on everything from coronavirus to all kinds of other important diseases like sepsis and such. Winston, we're coming up to near the end of our time. I know we have a lot of students and alumni on this call, and I wondered if you had any thoughts or messages for young people today who would be following something like your journey, trying to decide which way to go, what to study, whether to stay for postgraduate school, thinking about how to get into business. And you're an entrepreneur, you're a PhD, you're someone who's really seen a lot of different things in your life. What is your advice to young people today?
I think follow your dreams. Very important. I think as to Alice, what you say about postgraduate study, I never regret spending 4 years in postgraduate at Imperial College. Although I don't apply them directly in the business today, but the training, very important. Original thinking, very important. I think postgraduate training, especially a training like anybody who's lucky enough to go to Imperial College for a PhD training, I think it's going to benefit you for a lifetime. Success don't come quickly. It takes time, it takes patience, it takes lots of things besides your skill in the field. It takes people. It takes luck also. Okay, so and circumstantial reasons are important, but I think you never be successful without knowledge, without effort, without a great deal of endeavor. But you also need help from nature. If you are religious, you need help from God also.
Well, thank you very much. And those are very good messages to seize opportunities like you have, and find good mentors, hard work, and inspiration, and following your heart. So thank you so much for sharing your stories with us, and we look forward to many future conversations and watching the exciting new innovations coming from your work. So I'd like to thank everyone for joining us too, because these are really opportunities to talk to some of our great alumni. And thank you, Winston.
Thank you, Alice, and best of luck to everyone. And I always be thankful for my opportunity. In my lifetime, I can have 7 wonderful years at Imperial College. Thank you all. Thank you very much.
Thank you. Bye.
Thank you. Thank you. Goodbye. Take care, everyone. 好了。